So today's objective is to also simplify radicals. Previously, we learned how to simplify radicals such as square root of 9 over 100 by breaking the radical apart and simplifying them separately. Today, we are going to take this a half step further. We are going to learn how to simplify radicals such as the following. And it's not that much different, but it's still different than before. So here's how you simplify the radical. Here are the first two steps. You want to simplify the radical itself first. Afterwards, you're going to simplify the expression as if you're simplifying a fraction. Okay, so here's example number 1. So what I'm going to do, I'm going to take this square root of 25 and I'm going to simplify that first. Hopefully by now you can recognize that the square root of 25 is a perfect square. The square root of 25 is 5, right? So I'm going to rewrite it as 5 over 10. Why? Because the square root of 25 is the same thing as 5. Now I'm going to simplify 5 over 10. If I were to simplify 5 over 10, that is equal to 1 over 2. Okay, next, part B, same thing. You are going to simplify square root of 75 first. So for this one right here, it's not a perfect square, so you have to figure out what perfect square fits inside 75. And in this case, if you cut it in half and do, on how to simplify radicals, you would realize that it's the square root of 25 and the square root of 3, because 25 times 3 is 75. If I were to simplify the square root of 25 and the square root of 3, that becomes 5 root 3. So I'm going to substitute 5 root 3 instead of square root of 75. So now, don't forget the negative. It would become negative 5 root 3 over 25. And then you could also simplify this. When I simplify this, you are only going to simplify the outside numbers together. You cannot simplify inside the square root. You could only simplify outside the square root. So in this case, you are going to 5 and 25 can simplify to 1 and 5. So this would become negative square root of 3 all over 5. Why don't you try, here's one more. All right, this one right here, you're going to simplify the square root of 8. Square root of 8, the perfect square that fits inside is square root of 4 and square root of 2 all over 2. If I were to simplify the square root of 4, that is equal to 2 root 2 over 2. And as I said earlier, you could only simplify the outside numbers together, so this becomes 1 and that becomes 1. So this just becomes square root of 2 by itself. All right, why don't you try 1, 2, and 3 on your own. So for number 1, hopefully you can recognize the square root of 49 is 7. So you have 7 over 14. That is equal to just 1/2. Number 2, you have to simplify the square root of 54. This simplifies the square root of 9, square root of 6, which is equal to 3 root 6. So I'm going to substitute in 3 root 6 instead of square root of 54. So this would become negative 3 root 6 all over 27. As I said, don't simplify inside the square with the outside number. You're going to simplify just the outside numbers here. This would become 1. This would become 9. If it's a 1, you don't need to write it, so I'm going to write it as negative root 6 over 9. Remember, you cannot simplify the 6 and the 9 because 6 is inside the square root. Number 3, what perfect square fits inside 32? That would be 16 and 2. Remember, you're looking for the biggest perfect square. Some of you may have said 4, but 16 is larger than 4, so I would use that one. So you have 4 root 2. I'm going to substitute it in for this number right there. Rewrite it. You have 4 root 2 over 4. Remember, you're only simplifying the outside numbers, so these cancel out. So you're just left with the square root of 2 as your final answer. If you didn't understand that, pause the video, rewatch any portion of the video to help you out, and then we'll move on from here. All right, the last part of this lesson is the following. You're going to simplify this. So step 1 doesn't change at all. You are always going to start with simplifying the radical expression. The square root of 100 is 10, right? This is equal to just 10 because that is a perfect square. So instead of square root of 100, I'm going to substitute 10. So what is this going to be? 2 times 10 root 5, which becomes 20 over 5, which is just 4. Okay? This operation is 2 times the square root of 100, even though you don't see the multiplication symbol, that's what it is. All right, this one right here, you're gonna only simplify the square root of 40. Right, this is the same thing as 3 times the square root of 40. So now let's simplify just the square root of 40. It looks like the biggest perfect square that fits inside 40 is root 4 root 10, which becomes 2 root 10. So I'm now going to substitute in 2 root 10 in for 40. So let me rewrite it. So it'll be 3 times 2 root 10 all over 2. The outside numbers you can actually multiply here. So 3 times 2, you get 6. So I would continue going, 6 root 10 over 2. And remember, you could only simplify the outside numbers and not the numbers on the inside. So I could simplify this, 3 and 1. I'm left with just 3 root 10 over 1, but I don't need to write the over 1 part. Next, letter C, same way. Let's simplify the square root of 150 first. I would say 25, right? So this would be 25 and 6, which become 5 root 6. All right, now substitute this in back for square root of 150. So I have negative 5 times 5 root 6 all over 2. You're multiplying the outside numbers together, so I have negative 25 root 6 over 2. Some of you may think we could simplify this, but we cannot, because the square root of 6 is inside the radical and the 2 is not. So, and I cannot simplify the 25 and 2, so this is my final answer. Why don't you work on 4, 5, and 6 on your own? All right, for this example, square root of 9 is the same thing as 3. So I'm going to rewrite this as 3 times 3 over 81. 9 over 81, which then simplifies to be 1 over 9. All right, number 5. If I were to simplify the square root of 18, I could split this up into square root of 9 square root of 2, which is 3 root 2. Now substitute that back in instead of square root of 18. So I have negative 5 multiplied by 3 root 2 all over 3. Multiply the outside numbers, I have negative 15 root 2 over 3. Right, I can multiply the outside numbers together. That's what I did here. And then simplify. 15 becomes a 5. This becomes a 1. I'm left with negative 5 root 2. Last but not least, same thing. Simplify the square root of 72. If you split it into 2, you get 36. And 36 lands on a perfect square, so that's what I'm going to use. This becomes 6 root 2. Substitute this back in. Instead of square root of 72, we're going to plug in 6 root 2. 6 times 6 root 2 all over 5. If you multiply the outside numbers, you get 36 root 2 all over 5. You cannot simplify that, so that is my answer. Why don't you circle your level of understanding? How do you feel after today's lesson? If you have any questions, I'll help you out on the next day. Have a great one. Bye-bye.